In this movie, we'll have a look at the experimental setup we used internally in the Aspire project, and then also for the demonstration and validation purposes. The experimental setup mainly consists of a target platform and the use cases that we have to protect. So the main goals are to provide a testing environment, an environment where we can validate the end results of the project, where we can demonstrate them, and of course where we can do all the development of the protection toolchain, of the use cases, and of all the functionality needed throughout the project. Now at the start of the project we had some choices to make. The first choice was to go for a realistic, relevant platform. And the second one was to go for complex use cases, not just toy examples on which we would deploy the protections. As for the platform, we chose for Android 4.3 and then 4.4, which means we were targeting an ARM v7 architecture. And the reason was that at the start of the project, this platform was the one for which toolchains, developer boards, and so on were available. As for the use cases, we decided to go for native dynamically linked libraries and Dalvik apps. In those apps and in the use case scenarios, the dynamically linked libraries embed all the sensitive code and the sensitive assets, and so that's where we have to apply the protections, not on some toy examples just existing of a main function and some auxiliary functions, but real complete dynamically linked libraries. Of course, these choices have an impact, and the most important effect was that we would have to focus on embedded software development. We'd have to use cross-compilation rather than native compilation. We have to start using developer boards rather than running experiments on our desktops. And as such, it was not hard to foresee that we would be facing reproducibility issues during the project. When people from 7 different companies and institutes have to collaborate on the development of a cross-compilation toolchain and have to deploy use cases on developer boards and reproduce each other's problems and bugs, it's clear that they need to have a very reproducible environment to make this work well. So in the Aspire project, we invested quite heavily in the development of a common Aspire build VM. As a coordinator, we developed a virtual machine image that has a standard setup. For example, there are standard directories where all the tools and all the components of the protection toolchain are installed, and users can rely on scripts to set all these links to invoke different versions of the different protections. For example, at any time they can use development versions of a protection or testing versions, and they can combine them in many different ways. We also foresee multiple compiler installations both for Android and for Linux to make it almost trivial to reproduce compilation and protection results obtained by other partners. All development happens within this VM, and to share code we have set up different repositories. There's a repository where we communicate on general aspects of the project, but there is also a specific framework repository where we have support for different versions, like development versions, stable versions, and so on, of all the different components of our development, of our compiler toolchain, and of the decision support system. Now, providing such a VM that can be used to reproduce each other's experiments is not enough. You also need to guarantee that people deploy it in an identical way and set it up in an identical way. So we developed quite some documentation and scripts to automate the installation of new versions of software, to update the repositories, and to make everything as reproducible as possible. Also, for example, for setting up the test boards, there is a lot of information available on the internal web pages of our website. Now that we are on the subject of this Android board that we used for testing and validation and demonstration purposes, at the start of the project what we did is a big survey, and we researched all available boards that might meet our needs, and then eventually we selected one, and we made sure that every partner in the project bought the same boards, again to facilitate reproducing each other's results. So I propose we now have a look at that actual hardware.
Yes, so these are the test boards that we use to test the Aspire applications. We have 4 iMX6 boards using a Freescale chip. We also have an Armdale board that's made by Samsung and contains an Exynos processor. We also have a Panda board, which contains a TI OMAP processor. And for testing purposes, we have set up 2 of the 4 IMX6 boards with an Android system, Android 4.3, Android 4.4, and the other 2 are Linux distributions. For future testing purposes, we also have bought 2 ARM64 boards using a Qualcomm processor.
But those were not bought on a Spire budget, were they?
No, they weren't.
Okay, thanks. The Aspire project received funding from the European Union 7th Framework Programme under Grant Agreement number 609734.